Okay, so what we're going to do today is we're going to talk about that one last topic that you haven't seen for the extension. And what we're going to do is talk about something called simultaneous equations. Okay? Now, you might see these called systems of equations. And if you do see it, you'll probably see it because I've written it. I'm used to calling these systems of equations, simultaneous equations. Doesn't really matter what you call them. The process is exactly the same. And what you're going to be doing here with simultaneous equations or systems of equations is you're going to be solving two or more equations at the same time. Now, don't let that throw you. It's really quite a simple process. So let's have a look at it. So it's two or more. Now we're going to stick to just two equations. Equations. And again, we know they're equations because they have equal symbols. Two or more equations that have a common solution. So in other words, if x is 5 in the first equation, then x has to be 5 in the second equation. So they'll have a common solution. Now, you're also going to notice that there are also two variables. And generally, they have x and a y. Okay? So we have two equations in two variables, and their solutions are the same. And that allows us to be able to solve them at the same time. So what we're going to do is we're going to look at how to solve using elimination. So we're going to go through the steps and the processes for solving using elimination. Now there are other methods, but if you use the other methods, they're a little clumsier than elimination. It's the most foolproof, easiest way to deal with these. Okay, the other ways are only really work well if they're in a certain format or you see a certain way, and it's just not. Elimination is just easier and better. Okay, so our first step in solving using elimination. Well, first of all, elimination means that you're going to get rid of something. Yeah. So you're going to eliminate. What we're working to do here is we're going to eliminate one of the variable terms. So in other words, I want to subtract away either the x's or subtract away either the y's. Doesn't matter which one, but one of them. So the first step is to line up x, y, and then you'll put your equal, and then on the far side you'll have a constant. So this, and remember, constant just means a number. Right? So you're going to have an x term, a y term, and then the equals and a constant. You have to make sure that they're all lined up. So that may mean you have to manipulate the equation a little bit. Move an x term, move a y term, move your number away from the x and y, something. And we'll look at several examples of these. Now, on the test, they're going to be very straightforward because this is just an introduction to this. Second, we need opposites. And just going to take a moment to define what an opposite is. An opposite is same term, but different sign. So for example, if you have positive 4x, the opposite is negative 4x. Okay? So it just means exactly the same sign. They have to look identical, the only difference being the sign. Okay? Now, we may have sometimes to do something to get opposites, but you might also have an equation where you already have opposites, which is nice, but it's not likely. Okay? So you may have to multiply Just try to get the notes down, and then we'll look at some examples in a minute and how to use them. You may have to multiply one or both equations by something to get opposites. Now, this is not a problem for us because we know that you can do anything you want to an equation as long as you do it equally. So if I want to multiply all of them by 2, that's fine, as long as I multiply every single term in that equation by 2. If I just need to change the signs to get an opposite, that's perfectly fine. But if I change one sign, I have to make sure that I change them all. Okay? So remember, if you're going to do that, it has to be every term, not just some of them. Okay? This is usually where the most confusing part, just deciding what you want to eliminate and what you need to do to be able to eliminate it. But again, it's not a difficult process mathematically, it's just a matter of staying organized. So I'm going to pause the recording and give you a moment to write those down. Okay, well, once you have your opposites, the next step is to simply add the two equations together. And when you do that, when you add the two equations together, those two terms that have opposites are simply going to subtract away. Just like when you're solving an equation, the opposites will eliminate each other. So add the two equations together. When you do that, it's going to eliminate one of the variable terms. So this eliminates one variable term. Now, it doesn't matter if you eliminate your x's or you eliminate your y's. You're going to look at whichever one is easiest, and we'll look at some examples so you can help choose which one you think is easiest. Step 4 is simply to solve the resulting equation. Because once you've eliminated one of your variable terms, you're just going to end up with a simple linear equation to solve. You'll either solve it for x or solve it for y. And you're going to get one of the variables solved. Okay. Then you're going to go and use substitution, which we've talked about before. You're simply going to substitute that value into one of the original equations and solve to find the other value. Now, just like most things, this takes a lot longer to write than it does to do. So just solve to find the other value. And then there's one more step. You're going to write your answer as an ordered pair. And if you remember when I don't know that we've done graphing yet, but you've done some graphing in your past, that's x, comma, y. So you put your x value first and your y value second, and then enclose them in a bracket. All right, so we're just going to go to the simultaneous equations section. It starts on page 299 on your Snowflake book, and you're going to see that they're going to do several processes. The first one they talk about is just kind of a guess and check. Don't worry about that, trial and error. That's not a good method unless they're super simple. The graphical solutions is good when you have the graph, but if you don't have the graph, you're not going to know what's happening. But it does explain what the solution is. What we're doing here is we have two lines, and our common solution is where those lines cross. if they do cross, because remember, if two lines are parallel, they never cross. You could also have two lines that lay on top of each other, in which case they have an infinite number of common solutions. But what we're going to do is we're going to solve them using elimination. So hold on. So substitution is another process. Don't worry about it. We're going to go to substitution by elimination. It starts on page 305. So we're going to add the two equations together. Now, sometimes they're nice for you, but other times there usually going to be some work involved for you to do this. So let's look first. We'll just do 1A really quickly because it's nice and easy because they already have opposites. So I'll give you a chance to see what they do and how they work. So 5x plus 3y equals 12, and x minus 3y equals negative 6. And you'll notice this little notation. They put a brace on the outside. That's that squiggly type of bracket. It's called a brace. Now, and that indicates that this is a system of equations. Now, you can also see it sometimes where they put braces at both ends, but you can also sometimes they won't put anything at all, but then if they don't, then they have to tell you that this is a simultaneous equation. Okay? So they have to tell you some way, but usually it's just this using this special notation. Okay? So let's just go to some paper and look at them. So I know that this is a system of equations because they told me, or a simultaneous equation. And so the first step is to line it up, right? But if you notice here my x terms are here, my y terms are here, and my constants are there. So they're already lined up. Okay? So my next step then is to get some opposites. So what I'm going to do is look to see if I already have opposites. So 5x, the opposite of 5x is negative 5x. Well, this is not a negative 5x, it's just plain x, so they're not opposites. But 3y, the opposite of positive 3y is negative 3y. So in this case, we already have two terms that are opposites. So we don't have to multiply or divide or do anything else to these to get my opposites. I already have them. So the next step is to simply add them together. Again, because I already had opposites, I didn't have to worry about it. So we'll just draw a line, add them together. 5x's plus another x makes 6x's. 3y and negative 3y are opposites, so they're simply going to subtract away. And then bring down your equal symbol, and then 12 minus 6, of course, is 6. And what's happened here is I no longer have two equations in two variables, two unknowns. I have one equation with one unknown, just x. And all I need to do is solve for x. Now my x is on one side by itself, so the only thing left to do is simply divide both sides by the 6, which gives me x is equal to 1. Okay? So, solve. Okay? Now, I'm going to substitute. I need to substitute back into one of the original equations. And now, since I know what x is, I can plug it in. And it doesn't matter which one you use. We could use this first equation, or we could use this second one. Since the second one has just a plain old x in it, instead of multiply by 5, I can just put the 1 in place of that. That's the one I'm going to choose. But it really makes no difference. So in place of the x, I'm going to put a 1. But remember, you never replace a variable with a number without putting it in a bracket. Now, you might not have chosen this one because it has so many negatives. But now, to solve this, the bracket for the 1 in it, who cares? It doesn't really make any difference, does it? Because it's just all by itself. So you really didn't. That's the only case where you don't really need a bracket. I need to get my y by itself. So what I'll do is I'll subtract the 1 from both sides to get my y term on one side. Okay? And then I simply need to divide both sides by the coefficient. In this case, the coefficient is not just 3, but negative 3. So remember, you need the negative and the 3's to divide away. And over here, the negatives will divide away, and that gives me 7 over 3. So my solutions, and that's my y value. So my solution, right, remember, you write it in as an ordered pair. So that's your x value, and then your y value. And that's the solution. Now that one was particularly easy because they didn't give you anything. You didn't have to find the opposites. So, but most of the time you're going to have to find the opposites. So let's look at one of those. Okay. All right, so look at 4a there. 4a, we have 4x minus 3y equals 6. We have negative 2x plus 5y equals 4. So here's our system of equations. So we need to solve this system to find out what my x and y values are. So the first step is to line them up. Now they're being nice to you because your x's and your y's and your constants are already lined up for you, so you don't have any work to do there. The next step is that you must have opposites. So always look at the bigger value. So we have 4x is bigger than the negative 2x, but 4x and negative 2x are not opposites. So let's look at our y's. We have 5y. 5y and 3y, negative 3y, are not opposites. The good news is that this one's positive and that one's negative, this one's negative, that one's positive. So the good news is that we have opposite signs, we just don't have opposite numbers. So that means I can multiply to find the opposite. So I can't turn a 5 into a 3 or a 3 into a 5, but I can turn a 2 into a 4. And so that's where I'm going to concentrate. So what I'm going to do is I'm going to multiply this entire bottom equation by 2 so that will turn my negative 2x into a negative 4x. So let's do the multiplication. 2 times negative 2x is negative 4x, right? Now I have the opposites that I wanted, but I have to multiply every term. So 2 times positive 5y is positive 10y. And finally, 2 times my positive 4 is positive 8. And I'm just going to draw a line through that equation. Now, don't draw it so deeply hard that you can't see it, because you might want to come back in your substitution and use that equation, but you don't have to. You can just use the other one. Now what I'll do is add them together. 4x's minus 4x's make no x's. Negative 3y plus 10y makes positive 7y. And 6 and 8 will combine to make 14. Now I just have a simple linear equation. Right, so the third step was to add them together. Fourth step is to solve that little equation you have left. And all you're ever going to have to do here when you're solving that is just divide by the coefficient. So that gives you y equals 2. Fifth step is to substitute. And it doesn't matter where you substitute, but since I haven't written on this one, I'm going to use that one. You could use that one. You could use that one before we changed it. You could even use the one you changed. But if you use the one you change, you better make sure you didn't make any mistakes. So, in place of the y, excuse me, I'm going to put the 2 that I just got when I solved it. Make sure you remember you can't replace a letter with a number without using brackets. Okay? So, get rid of the brackets. 4x, negative 3 times 2 is negative 6, equals 6. Simple linear equation. First, I need to get my variable terms on one side. I only have one variable term, so it's not moving, but since I have 2 constant terms, I've got to move one of them. And of course, I want to move the one away from the variable term. So we'll move this negative 6, and the opposite of minus 6 is add 6. Over here, they'll subtract away. This gives you 4x. On this side, 6 and 6 makes 12. Now it's just a matter of getting rid of that 4. And since they're connected with multiplication, well, the opposite of multiply by 4 is divide by 4. So when we do that, we get x equals 3. And the final and last step is to simply write it as an ordered pair. So x value always comes first, even though we solve for y first. So make sure you get that x value first, and make sure that you enclose them in a bracket. So my common solution, therefore, is 3, 2. Okay? So again, you've got those exercises in substitution on your Snowflake. Go back to and find the pages for you, and you can look at some of these. I'm going to just give you some where you do have to do more of the work, because that makes more sense to practice the ones where you have to work on using the elimination. Okay, and I do want to show you. I didn't show you one where you have to multiply both. Let's look at that. So look at 5a, for example. So we have 2x plus 3y equals 7. and 3x minus 2y equals 4. So they're already nicely lined up, x's, y's, constants. But if you look at this, and look at the x's, the biggest x, can I turn a 2 into a 3 using multiplication? Nope. Okay. If you look at this, can I turn a 3 into a 2 using multiplication? Nope. Well, what that tells me is that I'm not going to be able to just multiply one of the equations by something. I'm going to have to multiply them both by something. So I'm going to concentrate on the y's in this case because one of them is already positive and the other is negative. So they already have opposite signs. If that's the case, try to use those because sign errors are a huge problem. Now, I can't turn a 3 into a 2, but I can turn a 3 and a 2 into a 6. So that's what we'll do. But in order to do that, I'm going to have to multiply not one equation, but both of them. I need to multiply the top one by 2 and the bottom one by 3. Again, because I'm trying to turn both of these into the same number. Think about least common multiple or least common denominator. You're trying to turn them into both the same number. Now let's multiply. 2 times 2x is 4x. 2 times positive 3y is positive 6y. And 2 times 7 is 14. Remember, you can't just multiply one term, all of them. In the bottom, 3 times 3x is 9x. 3 times negative 2 is negative 6y. Negative 2y, I'm sorry. And 3 times 4, of course, is 12. Now you'll notice that here in my y terms, they are opposites. It did change every number, but that's not going to matter because we changed them equally. So the 6y's are going to subtract away. 4x's plus 9x's are going to make 13x's. And 14 and 12 are going to combine to make 26. Then we'll solve by dividing both sides by 13, which gives me x is equal to 2. Now that I know one value, I can simply substitute it into one of the original equations to get my second value. And it doesn't matter which one. I'm just going to choose this one just because it's handy. So 2 times the 2 that I got for x plus 3y should equal 7. 2 times 2 is 4 plus 3y equals 7. We'll subtract the 4 from both sides to get the variable term by itself, which gives me 3y equals 3. And last step, of course, is always to divide by the coefficient, so y is equal to 1. Final step, write it as an ordered pair, 2, 1. So sometimes you might have to multiply both equations by something in order to get opposites. Okay, so again, you're going to be working on your snowflake if you want to work on some of these. The best ones to do here using these are going to be numbers 4 and 5. And again, that's on page 307. So page 307, number 4 and number 5 would be great ones to practice with because they don't have opposites already. You're going to have to create some opposites. All right, there you go. Thanks, guys.